Hey everyone, it's Chris and welcome back to another episode of the Weekly Coder. In this tutorial we are going to get into the basics of C# and programming and what it's what it's all about basically, right? So Unity is a very visual game engine where mostly you can just kind of drag and drop stuff all over the place. And those are called game objects, right? Every time you create something in Unity, it's a game object. You put it into the scene and move it around, put it wherever you want. And that's one way to utilize Unity. The other part is the actual programming aspect where you're going to add functionality to those game objects. And that's where scripting comes in. Programming, C#, all that stuff. So, and scripting at the very basic starts with a file. So you create a script, right? By creating a C# script, you create a file. And then in that file, you start to write your code. And that basically tells the game object what it's going to do in a way. So we're going to get into all of that. So what we're going to start with is we're going to create a script. All right, I've already gone ahead and started creating a new project. I called mine C# 101 Classes and Variables because classes and variables to me is probably the basic, the most basic part of creating a script, right? What I like to do is, in my assets folder, I like to create a folder called scripts, which is where we're going to store all of our scripts and just kind of keep everything organized and in one spot, and to keep my OCD at ease, right? So, to get started, we can click on the scripts folder, and then in here, we can right-click and click Create and C# script. Now we're going to call this, we're going to call it car. Could we call it car? Let's call it enemy. Right? Because in most games, you're going to have an enemy. And what better way to start than with an enemy class, right? So, sorry, getting ahead of myself here, call this an enemy script. Because this would be attached to an enemy game object, or once we get more into the terminology of things, we would call this the enemy base class, because we would create other enemy scripts based on this class, and then those classes would basically inherit from this class. And now I've gone way over everybody's head, because hopefully if you're watching this, you don't know anything about classes and variables, and what I'm saying right now is not going to make any sense to you whatsoever. So before I continue to talk more and completely get ahead of myself, let's go ahead and open up this script and kind of analyze what's in there. And to open that up, you just double click on it, and then it'll launch MonoDevelop, which is the editor that we're going to use to edit all of our scripts. So double click that, and here we've got our enemy.cs script. Okay, and whenever we create a C# script in Unity, Unity is really cool, and it creates all of these things here for us, and we don't know what those are. So first time user ever opening up Unity and then creating a script, you launch this and you're like, oh my god, what am I looking at here? I don't know anything about programming, I don't know anything about C#, what does all of this mean? And that's what we're going to get into. What does this all mean? Well, basically, we with Unity and any kind of programming language, C# in particular, has what are called namespaces, and namespaces are basically a collection of classes that you can access certain functionalities of. So and when I say classes, they will mostly be other scripts that have already been created by Unity that we can access certain properties and methods from. You don't know what properties and methods are, that's okay. You don't need to know that right now. And I probably should have called this classes and variables and methods. Maybe we'll talk about methods. Maybe we'll talk about methods later, but let's talk about namespaces first. So Unity Engine. Okay, so this using statement tells Unity, hey, we're going to use Unity, the Unity Engine namespace. And the Unity Engine namespace comes with a whole bunch of classes that Unity's created to allow us to interface with the Unity engine. So anytime you reference any of the classes like game object or anything like that, that would be in the Unity engine namespace. Okay. And once we get more into the programming part, you will understand more about what a namespace is and what how you can add other namespaces to have other functionality in other classes. Okay. So, using system.collections, again, this is another namespace that gives us classes that we can access, and that's mostly part of C#. Okay, and so the next line is blank. Line number 4, we've got public class enemy : mono behavior, and we've got a little open curly bracket. And then if you click next to this, it'll highlight this little curly bracket here at the end. That means that curly bracket is responsible for enclosing everything inside of this right here. Okay, so our class is called enemy, and this open curly bracket says, hey, I want to put stuff inside this class, such as this right here, void start, and this right here, void update. And then I'm done with my class, so I'm going to close with a closing curly bracket. Okay, so this whole thing right here, this is our class. Okay, this is our class, and our class is named enemy because that's what we called our script. And Unity automatically creates a class based on the name of the script that we decide to create. Okay. Now, and a class. So a class is basically a base to start from. Or not a base to start from. It can be a base to start from, but it can also be an inherited class that takes properties from other classes. So what a class really is like a template. Okay, so we're making an enemy. Okay, and to define this enemy, we need to say, hey, this is a class. This is going to be an enemy, and in order to define our enemy, we're going to add what are called variables to give our enemy some behavior, some kind of things that it can do, like what its walk speed is going to be, what its damage is going to be when it interacts with the player, how long it should live for, or how strong it is, and all those things are going to be encompassed inside this class. Okay, what color it is, or whatever you want to add to give definition to your enemy class. This right here, okay, we've got a colon, and then we've got mono behavior. Mono behavior basically means that, mono behavior doesn't mean. This statement here says, hey, we've got this public enemy class. We could actually do this, and our class would work just as well. The only thing that we wouldn't be able to do is we wouldn't be able to reference these two methods, start and update, because start and update are part of mono behavior. So in order to use start and update, we have to inherit from mono behavior, or also we can call this extending mono behavior. We're extending mono behavior with the class of enemy. Okay, and what that means, and let me get into that in a minute. But we've got two methods here, and these are methods. Okay, this is a method inside of a class. This is a method inside of a class. So we've got this void start. The void is a keyword that's used in a method when you're creating it to say, hey, this method is basically going to just do what it does, and it's not going to return any kind of value whatsoever. Same thing with this, the update method. It's going to run, and it's just going to run. It's not going to give us any value back at all. It's just going to do what it needs to do, and that's it. We're not going to expect it to give us anything back. So the start method, for instance, okay, it's part of mono behavior, and what happens with the start method is that anything that you add to the start method in your script is going to execute when your game object is initialized. So let's pretend for a second that we've created this script, this enemy script, and that we've created an enemy game object. And let's pretend that we've taken this script and attached it to our enemy game object. And let's further pretend that we've taken our enemy game object and we've put it into our scene. And along those same lines, we're still pretending here that our scene is loading when we start up our game. So when our scene loads, Unity says, hey, what are all the game objects? So it takes all the game objects and says, okay, well, we've got all these game objects, we're going to initialize them. They're part of the scene, so we need to initialize them and go ahead and do what the scripts say to do. And this right here, this start method, is called once your game object gets initialized by Unity. When you run your game and your game object that has this script attached is in the scene, then whatever is in the start method is going to run. And you know what? I'm going to actually demonstrate this for you guys. So in here, we've already got a game object in the scene. We've got the camera. So let's not deal with that right now. We're actually going to add a new game object. So we're going to just create an empty game object. Okay. And you'll see here in our hierarchy, we've got the game object. Now let's call it enemy. Okay. And then to add a script to a game object, we just take this script and we drag it over here into the inspector. And now we've got our enemy script attached to our game object. So now if we press play, nothing happens. We've got nothing in our console, nothing on the screen, nothing at all. And that's because our script is empty. Our script doesn't do anything. Okay? So, and you know, you don't have to know any of this right now, but this is for demonstration only. So if you're not following me here, that's okay. But what I'm going to do is I'm going to add a debug.log statement, and debug is a class. Okay, so we've talked about classes, right? So debug is a class, all right, and that's part of the Unity Engine namespace. Okay, and just to demonstrate how we can access classes that are part of Unity Engine namespace, I'm going to go ahead and comment out using Unity Engine, which means we can't access any of the classes, which means we can't inherit from mono behavior. So we're going to have to get rid of this because that's an error now. So now if we want to write debug, it doesn't exist. There are no code completions for debug because debug is a class within Unity Engine. So now we're going to use Unity Engine and we're going to inherit from mono behavior, which is a class inside of the Unity Engine namespace. Now we can go back into our start method and we can use debug. And the debug class has a method called log. And with the log method, we can actually print out to our console. So to print out to our console, we're going to say hello world, close parentheses, and always end our line with a semicolon. I'm going to save this. I'm going to press play. Okay. Now look what happened. Still nothing on the screen here, but in our console, we've got this little hello world. And that proves to us that when we created this game object in our hierarchy that's part of our scene, and we attached our script to it, the start method is called when this is initialized, and this statement gets called when the start method runs. Okay? And the start method will only run once, when the game object is initialized, when the script is initialized. Okay? This is only going to ever run once. Okay? So we've got another method here, update. Update runs, ideally update runs 60 times a second. Basically, and this is what it's telling you, update is called once per frame. Okay, most games run at 60 frames per second. So every second, whatever you have in your update method, okay, also we call this an update loop, a game loop, because this continuously runs over and over and over and over and over again, once per frame. Okay, 60 frames per second, 60 times per second. 60 times per second, this thing runs. So if we take our hello world out of the start method and we put it in the update, save it, press play, now watch what happens. See that little bar over here going down? That's because hello world is being written to the screen 60 times per second here in the console, okay? And it's just going to keep going and going and going and going and going and never end until our game object is no longer part of our scene, because this is going to run. It's in our scene, it's going to continuously run, okay? So that's where we're at. We've got start and we've got update, and those two methods are derived from MonoBehavior, from the MonoBehavior class. And that's really all you need to know about that, okay? The start and update methods need MonoBehavior, need your class to inherit from MonoBehavior, because you could create a class that doesn't inherit from MonoBehavior, and there are instances where you might want to do that, but generally if it's going to be a game object and it's going to need a script, you're going to want to inherit from MonoBehavior, because that game object is going to need to access classes and methods that are part of MonoBehavior. You're also going to want the Unity Engine namespace, because you're going to want to be able to access classes that are part of the Unity Engine namespace. Okay, so again, namespaces that have classes that we need access to, the class that defines our game object, the methods that are in our class. Okay, so let's talk about variables. Variables are such a huge part of programming. They're used for everything. So there are a couple of things when you're defining a variable. There is the type of variable that you're creating, and whether it's a public or a private variable, whether it's a static or dynamic variable, whether it's an integer, a string, a game object, a transform. What kind of variable is it? What kind of information is going to hold? Vector 2, vector 3, those kinds of things. What is this variable going to be used for? So, for our enemy class, for instance, okay, we can define some attributes, properties for our enemy, and those would be variables that we can then later change or inherit from in a more specific enemy class. So we want to start out with, let's say, a walk speed, and we can do walk speed with an integer, or we can use a float or double. Generally, for something like a walk speed, for instance, you would want to use a float. Okay, so, and there are a couple of ways that you want to define this, right? So let's say that you want to create a walk speed for this enemy, but you're not sure exactly what the walk speed should be. So you want to kind of test it and adjust it to fit what the walk speed, what actual speed you want to use. So in order to do that, through the inspector, you would have to define the variable as a public variable so that the inspector can have access to it. Otherwise, if you defined it as a private variable, the inspector would not be able to see that variable, and you wouldn't be able to adjust it. So let's start with the keyword public. Okay. So we know our variable is going to be a public variable, but what else do we want our variable to be? Well, we want our variable to be a variable and we want it to be a float. So a float, basically, you would use the float keyword. So now we know that our variable is going to be public, and it's going to be of type float. So now the kind of last thing, not last thing, but next thing is we want a name for our variable, something that we can reference it by. And the best way to name variables is to be as descriptive as you can, so that you know what they are. So you're not going to create a variable name like this, because that's not going to help you define what that variable is, or xx12 or 321. That is not going to help you. It's only going to make your code impossible to read. So for something like walk speed, we would just say walk speed. Okay? So we're creating a variable called walk speed. And one thing about variable and how to name them is you'll notice that the first letter of my variable is lowercase, and the first letter of the second word of my variable is uppercase. Variables cannot have spaces. Variables can, however, have underscores, so you could write it like this. But my preferred way of creating variables is camel case. Camel case is capitalizing the first letter of every word that is separate in your variable. So walk, speed, fast, something like that. So you would have lowercase, uppercase, uppercase. You always start variable names with lowercase. Class names start with uppercase. Method names start with uppercase. But variable names, always start them with lowercase. And that's just a naming convention that I like to stick with. Of course, you can name your variables however you like. Use whatever style you prefer. That's the beauty of programming. As long as you stay consistent, nothing, it doesn't really matter. So, walk speed. So you can actually further define this variable. You could end it right here and say, okay, I've created a variable called walk speed. It's a float, and it's public, and I'm done. But what if you want to go ahead and say, okay, well, I kind of know about what I want my walk speed to be, so I'm going to go ahead and assign it a value, which you can do. So to assign it a value, you would just add the equal sign, and then do another space, and then you would assign it a value. Let's do 3.0f. Okay. And when you're defining a floating point variable, you always have to add the f at the end of the value for this variable. Otherwise, you're going to get compiler errors in Unity, because it wants you to be sure that you're creating a float. So we're adding an f to basically tell Unity that this is a float. Okay? We're defining a float, so we're giving it a float value. So now we've got a variable created. If we save this now, and we go back to Unity and look at our enemy script, okay? So you can see that Unity has taken our variable and actually has formatted it properly. So our camel case type of defining variables actually helped us out here, because Unity just took that and created two words out of it called walk speed. And here's our default value of 3. Great, right? Okay, so if you're running this, right? Because and that's the cool thing about creating public variables that you can access in the inspector, is because you can be running your game, okay? And while you're running the game, you can adjust this value until you find a value that you like. The only thing is, you got to remember that, like, let's say, oh wow, I really like 4.59. That's perfect walk speed. So I'm going to go ahead and stop my game, and here's what happens. It goes back to the default walk speed. It does not save those values. Those values are only there when you're editing or when you're playing, when you're playing your game. And so if you find a value that you like, make a note of it, because you'll have to change it then manually, okay? So back into our enemy class. We've got our walk speed set at 3, okay? And just to kind of demonstrate our update, we can now, in our update loop, we can write debug debug.log again. And this time, what we want to do is we want to show what the walk speed is. Okay, so we're going to save this, and debug.log is going to print out what the value of the walk speed variable is. At first, it's 3. Okay, that's the number that's assigned to walk speed. So it should output 3 to the console over and over and over and over again. Okay, so let's go ahead and play. So here we've got 3. So now if we go over here and adjust this, you'll see that when it prints out our value of walk speed, it is printing out the value that we change walk speed to. Okay, because we're updating the value of the walk speed variable, and our update loop prints out whatever value is in the walk speed variable. Okay, simple enough, right? And that's basically variables. That's how you would access variables. And there are so many more variables, or so many different types of variables that you can define. You can define, for instance, if you wanted to define a location, right, for your enemy, you could do public vector2. Let's say we want a starting position for this enemy. So we would do a vector2 starting position. Okay. And we can assign a starting position of, let's say, 0, 0. Okay. So when we save this and we go back into our editor, we now have starting position that we can define for our enemy. Okay, and it's set at 0, 0 because that's what we made our default values. So now that we've defined our starting position, with 0, 0, we want to print out what our starting position is. Okay, so let's go with debug.log. And starting position is a vector2. So our starting position variable actually has 2 properties. It has an X property and a Y property. So we can print that differently. So first we're going to do a quote, and then we're going to write starting position X, and then a closing quote, and then we're going to add a plus, and that just concatenates the string, the variable. So starting position dot X to access the X property of our vector, and then we're going to add another plus and another quote, space, or comma, space, Y colon, and then another quote and a plus, and starting position dot Y. So this will print us out this whole line and tell us what the value of X is and what the value of Y is in our starting position vector2 variable. So when we press play, starting position X equals 0, Y equals 0. If we update it, same thing. Those change because the value of our variable has changed. Okay. So coming back, variables. Variables are basically a way for you to store data in code and to access it and manipulate it. Okay. And then methods access those variables to perform various things, right? So let's say we've got our enemy class. And, we've got different types of enemies. We've got a robot and a rabbit and a dog, a zombie, whatever. So these different types of enemies could all inherit from this enemy class. Just like enemy inherits from mono behavior, we could create another enemy class that could inherit from enemy, from our base class enemy, right? So let's just jump in real quick here. Create C# script. We'll call this zombie enemy. So now I've created a class called zombie enemy. All right. So by default, it's inheriting from mono behavior. We want to inherit, however, from enemy. Okay. And we still have access to start and update because enemy extends or inherits from mono behavior. So basically, we're inheriting from mono behavior because we're inheriting from enemy. So now zombie enemy automatically has access to the values of walk, walk speed, and starting position. And to demonstrate that, we can do this, debug.log, walk speed. See how we can just write walk speed and we didn't define walk speed anywhere in this class? It's because we're inheriting from the enemy class. Walk speed in the enemy class is set to default to 3. Okay. The other thing that happens is we can now go to our enemy class. We can remove the enemy script. We can add the zombie enemy script. And look, we've already got our walk speed and our starting position. Even though we didn't create them in here, they are in our enemy class, okay, our base class that we're inheriting from. So we get access to those because they're in our base class, okay? So when we do walk speed, same thing, it's going to output 3 to the console, and we can change that here just like we could with our base class for our enemy. So why get into all this base class, inherited class, blah, blah, blah? Well, because let's say you create a zombie, and then you create a dog zombie, or like let's say a human zombie, a dog zombie, a bird zombie. They may all have the same walk speed, except for the they may all have the walk speed property, but they may not all have the same walk speed. So instead of in every class creating the walk speed variable and setting it, you already have the walk speed variable available to you. Just like the starting position, every one of your enemies is going to have that starting position. But you don't want to have to create the starting position variable in every one of these classes. You only want to have to create it once and then just inherit from a base class and then be able to utilize those variables in your other classes. I may have gone beyond just the basics of classes and variables, but I think hopefully I'm doing a good job explaining this. If there's any questions that you guys have about anything that I've said, feel free to ask. I will answer anything. I will answer any questions you have about classes and variables. Let's leave it at that. So classes and variables. That's basically it. There isn't much more to it. You know, we've covered the namespaces, Unity Engine, how that's a namespace and how that has a collection of classes that you can access methods and properties from. We've talked about, you know, what this is. This is your actual class. Okay. Many times when people create scripts, they actually refer to them as classes because that's basically what it is. You're creating a script which is a class. The class is this though. This is anything that's here is your class. Any kind of method you have, like start and update, is part of your class. Okay. So I think that probably covers variables. Well, I don't know. Let me show you guys one more thing here. Just something simple that you can do. You know what? No, let's get into that when we get into the next tutorial that's going to cover methods. That's probably what I'm going to do next because I think it's the next logical step to take. is covering methods and parameters for methods, and how to use variables and parameters, and how to manipulate those variables, and how to get return data back from your methods that you create. So a lot of stuff over your head, I know, but it's okay. We're gonna get there. And if there's anything that I missed, if there's anything that you think that I should elaborate on a little more, any kind of questions you have, feel free to comment. I will respond back. Don't forget to like the video, thumbs up, okay? And don't forget to subscribe to my channel. That's important to me. I love subscribers. I like creating this content, and every time I see a new subscriber or two, it gets me excited about creating new content, because I actually see that there are more people who are interested in watching what I've got to create. So with that said, I'm going to go ahead and end the video here. Again, don't forget to like and comment down below, subscribe, and I will see you guys next week.